Hi everyone, in this video I'm going to recap some of the information that I delivered to you on the fifth session of our workshop series. So if we first just think back to what we did in that session, we basically built an audio looping patch that allowed us to record audio in, loop it back, and do some basic audio manipulation techniques, so things like playback speed. We also quickly went over some objects that allowed us to graphically view the audio that we've recorded in a similar way to how we see audio waves on Logic and Pro Tools. So basically in this video I'm going to show you how to build that patch. I'm going to step you through it again, tell you what all the objects do, and the aim here is that you guys can go home, rebuild this object with a bit of instruction on the video, and get to grips with what some of these things are doing. And this patch actually covers quite a lot of concepts, so things like how to record into memory, how to play back said recording, and also how to, like I said, change playback speed and stuff. So let's start from the beginning. So if we're going to record audio into our computer, we need to be able to define somewhere in memory that this audio is going to be stored. So somewhere in our computer memory that's going to hold this information. Now, in computing jargon, this piece of memory is called a buffer. Okay, and that basically means that it's a piece of computing memory that we've allocated to store information in, and that's what a buffer is. Now, you've probably heard this term buffer around your kind of general use of a computer. Things like when you're watching YouTube videos, it might say buffering, when it's gathering information and storing it so you can play it back and so on. So it might be a term you've heard before. So in Max, to create a buffer to record into, we just create an object called buffer. So as we said, Max objects are quite intuitively named. So buffer tilde, so this tilde object here, this tilde symbol here means that this object is designed to work with audio samples. And if we press spacebar, it will tell you what arguments we can give to this buffer to change the way it works. So you can see here we can give 4 arguments. So the first is name, and the name can be given as a symbol, which means it could be a word, no spaces, so just one word. But this argument is actually required, so it's necessary to define a name, otherwise you can't use your audio buffer. There's a good reason for that. So basically, if you're storing information into your computer, you need to name that place so you can access it to play it back, or so you can access it to actually retrieve the information. If you don't have a name, then you don't know where the information is stored. So in this case, I'm going to call this loop 1. Okay. Now the other arguments are file name, duration, and channels. So file name is where we can define a file on our computer, and then the buffer will upload that file into its memory, which means we can work with pre-recorded audio files. Duration basically means how much memory is allocated to this buffer, so how much audio we can record, and this is quite important, and we'll go over it in just a second. And then finally channel, so whether we're working in mono, stereo, surround sound, or whatever. In this case, we're going to work with mono, which means that we don't have to define anything because that's the kind of initialized state without us having to change anything. Cool. So we have our buffer. Now if we lock our patcher, double click on the object, it actually brings up a window. And in this window, it will show you when you've recorded information in the waveform that you've recorded in. So this will look kind of like your tracks in Logic and Pro Tools. Now, before we start to use our buffer, we actually have to say, okay, how much do we want to record in? What amount of memory are we allocating to this object? So to do that, we need to send this buffer a size or a duration. Now we could define that here, where it says duration here, so we could type in a number like 500, 5000, but what we probably want to do is be able to change that dynamically. So all objects in Max are designed to listen to a whole range of messages, okay? So when a certain message, which is a word, is received in its inlet, that message corresponds to something that object does, and then it will action it when it receives a message. So for example, this object is designed to listen to the message clear, and when we hook that together, when it receives the message clear, it will empty its buffer. Now this is actually quite useful because we are likely, if we record something that we don't like, it's quite likely that we might want to get rid of it and delete it. So you can create this object here by pressing M on your keyboards, typing in the message clear, hooking it up to your buffer object, and if you lock your patcher and click on the message object, every time you click it, it will send whatever you've typed in here to the buffer object, which means it will clear its content. So let's keep that there. So along with the clear message, we want to be able to redefine its duration, as we were just talking about. So this object's actually designed to listen to the message size, and when it receives size, it takes the number afterwards and uses that number to allocate memory to the buffer. And this number is represented in milliseconds. So if we send it size 1000, the buffer length will be 1000 milliseconds, which means we can record 1 second's worth of audio into this buffer. So to hook that up with a number box that we can edit, we first need the number box, so I on our keyboards, and then we need to prepend to this number the word send. The message size. So we create the prepend object and type in size as its argument, hook that up, and you don't have to do this at home, I'm just showing you. So here you can see that now the number I type in here goes to the prepend object. The prepend object puts size before it, so it prepends the message size and then sends that out as output. And then if we pop that into our buffer object, we can now define the duration in milliseconds. And we can actually see that on the buffer window. So if I type in 1000 here, double click on the buffer window, so I'll just scroll that down, you will see that we have a time bar at the top which shows you the length of the buffer. So you've got 250 milliseconds, 500, 750 and 1000 here. If I type in 500, double click again, you'll see that I get different time markers at the top. So you can see that the buffer's memory size is changing. So if we put 2000 there, we'll just work with a buffer length of 2000 milliseconds, which means that we can record 2 seconds worth of audio into this buffer. Now, just so we remember what this number object's doing, let's create a comment box. See on your keyboards, type in buffer duration ms for milliseconds, just so we can remember what it does. Okay, so great. What we've actually done here is we've defined a buffer. We can change its size in milliseconds, and we can also clear it. Cool. So what we need to do next is be able to create a way of recording into the buffer. So taking audio and recording it into our buffer. Now, there's a special object to do this for us, which is called poke tilde. So again, the tilde symbol means that this object is designed for working with audio. We press space, you can see the two arguments that this object allows us to define is buffer object name, symbol, and again it's required. So we type in the name of the buffer we want to record into, so loop 1. Okay, and again we can have, so for example, here we could have had this as stereo, so it would have had 2 channels, and here it allows us to record into one of the channels that we've got in our buffer. So if this was loop 1 and this had 5 channels, I could type in channel 5 and I'd only record into channel 5 on this buffer. Okay, but because we're working in mono, we actually don't need to define anything because it's only 1 channel that's available. So here we have a poke object, and this object will allow us to record samples into the buffer. Now, the poke object has got 3 inlets, so let's just hover over them to see what they do. So this one is sample value to write, so that's basically the audio that we want it to record. So sample basically means we have a computer that's sampling our microphone input at 44100 Hz normally. So basically I'm speaking, hits the microphone, gets transduced into a voltage signal, which goes into the computer's ADC, which is its analog to digital converter, and every second it takes 44,100 samples. So that's basically individual data points from that voltage, which it's then going to send in to our poke object. Okay, now all of this information is coming in to the computer, and we want to store it into the loop 1 buffer here. However, we need to tell the computer how to organize it. Okay, so we need to tell it what order the samples are. So when we play them back, we know that sample 1 is sample 1, that's the first sample that should be coming out. Sample 2 is sample 2, that's the second one that should be coming out. If we don't do that, then the computer doesn't know what order the samples need to be played back in. So if you hover over the second inlet of the poke object, you'll see it says sample index. And that's exactly what that input's for. So it's basically, as we're sending in the samples here, which will be 44,100 a second, we need to give each of those samples a value. Okay, so if it's value, if we've got one sample coming in from my voice, we need to give, and that's the first sample, we need to give that value 0, because that's the first one. The second sample coming in needs to be 1, third needs to be 2, and so on and so forth. Okay, so first of all, let's get our audio in. So new object, ADC, analog to digital converter, little tilde because we're working with audio again. You press space, you see you get the arguments come up. So inputs, input 1, because I'm just using my microphone, so one input here, which is input 1, and we just hook that into our poke object. So these are the samples we want to write into our buffer. Now, we need to send in an indexed value, and there's a special object that does this for us, and it's called count tilde. Now the count tilde object, that says here, counts samples elapsed. So what that means is when we turn our audio on, this object will count the samples for us. So it'll go 1, 2, 3, 4, 5, 6, 7, 8 at the sampling rate of the computer. So it'll be synced to the sampling rate that's coming in from our microphone. If we press space, you'll see the arguments that we can give. Initial value, so that's basically where the counter starts. So if we wanted to start at 5, we would put 5 there. If we wanted to start at 0, we'd put 0 there. So let's put 0. So count limit, so that's the value that we want it to count up to, so the maximum value that it can count up to. So let's put 44,100 there. So that means it will count from 0 to 44,100, and that will take a second because we're sampling at 44,100 hertz. Okay, we press space again, we've got the next argument, which basically says enable, which isn't hugely descriptive, but what that basically means is, do we want this object to start counting as soon as we turn our audio on, or do we not? And basically we do, so we'll put 1 there. If we didn't want it to do that, we'll put 0. So we'll put 1 there, and then auto reset. So what the auto reset argument will do, will basically tell the object whether to start the count again when it reaches the maximum number. So when it gets to 44,100 in this case, do we want it to go back to 0 and then count up again? So is it looping around, or is it just doing it once? So we want it to loop around because we're creating a looper here. So let's press 1 there as well. Hey, if we didn't want it to do that, we press 0. Cool. So now, if I hook that into our index, we have our audio signal coming in. Each sample coming in from here is being given an index that's synced to our sample rate. So the first sample that comes in here will be given 0, the second will be given 1, the third, and so on and so forth. Okay, so now if I turn the audio on, we should see the audio being recorded into our buffer. So if we turn the audio on, double click on our buffer object, so we bring out the window, and you can see that we are now recording into our buffer. Okay, it looks just like it does on Pro Tools or Logic. But what do you notice about this? It's actually only recording up to 1,000 milliseconds, so it's only recording 1 second's worth of data, then it's going around and looping again and recording over it. And the reason for that is because we're only counting to 44,100 here. Okay, so as soon as it gets to 44,100's worth of samples, it goes back to 0, which means it overwrites sample 0, sample 1, sample 2, sample 3, sample 4, sample 5. So it's actually overwriting the samples at those indexes. Okay, so with 44,100, we can only record 1 second's worth of audio because that's how many samples there are in 1 second. So if we change this, for example, to 88,200, so we double it, go back to our buffer object, you'll now see we're recording over the whole lot. Okay, so let's just turn the audio off. So what we actually need to do is sync this value to the value that we're typing in to our to define our buffer size. Yeah, so these need to be synced to make sure we're recording across the whole of the buffer, so not just a proportion of it. So the way we do that is if you hover over the right inlet of your count object, you'll see that it says we can actually set the initial count limit by sending an integer, so integer, into this inlet. Now, this object, as you'll see here, is working in a sample range, not a millisecond range. So these two are in different scales. So this is milliseconds, this is samples. So we actually need to convert milliseconds into samples to hook these two together. Now we could do the mathematical calculation where we work out just times our sampling rate by the quantity of seconds that our buffer duration is set at. However, there's an object that actually does the calculation for us, which is called ms2samps tilde, okay, because it's working with samples again. As you can see, this converts milliseconds to samples. So this object is similar to the M to F object, which translates MIDI to frequencies. So we can now hook up our milliseconds in, and let's just hover over the outputs to see what this object outputs. So first of all, it outputs a signal here, or it outputs samples at input signal. So this is data and this is samples, okay, because it says signal here, where it doesn't say signal here. So this needs an integer, so it needs data, not samples. So we hook those two together. So now, if we change this to 1000, double click on our buffer, you can see it's 1000. Now if you look at the timestamps on the top, turn the audio on, we're now recording across the whole second. Okay, let's close that and change that to 2 seconds. Now we've got a 2-second long buffer looking at the top, and we're also still recording over the whole lot. So let's just turn the audio off. So now we have part of our patcher that defines a buffer, creates a buffer, which we can change the size of, and then we have a bit here that records into the buffer, so we can now record samples. So that's a basic way of recording into a buffer. Now we're going to slightly augment this so we can pause and stop the recording, because that's a really useful function. When you got the audio on, you might want to be listening to the audio and not playing it back, so you might want to pause the audio. So to do that, we basically need to manipulate this indexing signal. So if we provide loop with a signal that of a value here that isn't a valid signal to index with, so it's basically like -1, because -1, there can't be a memory allocation of -1 because it doesn't exist, it can only be a positive number, then the audio can't be stored. So that's essentially pausing the recording. So that's what we're going to do. So let's delete this cable here. Let's just move that one up. And let's create a static signal of -1. So to do that, we just use sig, because that creates, if we go back, convert numbers into audio signals, but we want to create a static audio signal. So here it says initial output value, we want it to be -1. So now we have this output that when it's connected to here, it will record the audio, and this object, when we connect to here, it will pause the audio. But we need to create a mechanism to switch between the two, yeah, maybe with a toggle or something. And there's a special object that allows us to do that, to switch between signals, and it's called selector tilde. So as you can see here, it says assign one of several inputs to an output. Okay, and it's got a tilde sign there as well, because that means it's designed for working with signals. Press space, so we can see what arguments the object has. So here we have 2 arguments. First one is number of inputs, and the second one is initially open inlet. So the number of inputs, which is defined as an integer, here is going to be 2, because we have 2 inputs. And then it's initially opened inlet. So this basically means which of these 2 objects do we want to be going to the output when we turn on the patch. So let's say 1, because we actually want this one to be on when we first turn on the patcher, so it's not just recording from the outset. So then we press enter, connect our signal to this one, and our count object to here, and our selector object into the indexing input of our poke object. So I'll just tidy this up so you can all see. Cool. So now we have a selector object that's going to allow us to choose between this signal or this signal. So whether or not, so which one of these two comes out of this output. So whether we're pausing or whether we're recording. Now, to select between these two, we basically need to tell the object, or send the object the message 1, which would correspond to this one, or the message 2, which corresponds to this one. Okay, and that needs to go into this inlet. So to do this, what we're going to do is use a toggle. Now, a toggle object, if I just show you, outputs a 1 if we turn on and a 0 if we turn off. Now this needs a 1 or a 2. So we can change the functionality of this to correspond to what this object requires by just making a simple plus object, put in +1. So now, when we turn it on, it will output a 2. And when we turn it off, it will output a 1. So it's turned off here, which means we're pausing the recording. Turned on here means we're recording. So, and we connect the plus object into the selector object, like so. And then, so we know what this is doing, let's create a comment box, see on your keyboard, just call it record on/off. Cool. So now, we should, if we turn our audio on, we'll be recording when I do this. So let's have a look, we're recording. Okay, let's close that down, turn this off, double click on the buffer, we're now not recording. Okay. Cool. So now we have a patcher that allows us to define a buffer length, record into it, and also pause and start the recording. Great. So what's next is we want to be able to play this information back. Yeah, so we want to be able to play this out of our speakers. So because there's several objects that allow us to play back audio from a buffer, but because we're looking at kind of the looping functionality, what the object we're going to use is called groove, okay, which is a variable rate looping sample playback. So it's basically an object that will access a buffer and play back the information and loop it. So it will basically loop the audio round and around. If we press space on our keyboards to see what arguments we need to give it, so here it says buffer name symbol required, so just like these two did. And because we want it to play back loop 1 buffer, we just type in loop 1. And again, number of outputs. So if this was 2 channels, we could put 2 here, and then we could play out both channels. But because it's only mono, we don't need to worry about that. So we just press enter. So we have the groove object. Now, the groove object, functionality slightly not necessarily 100% intuitive to understand. So I'm going to step you through it, but the logic behind it is not always clear in terms of its functionality. So to get this object to play back, you need to send it in its left inlet, the starting point in milliseconds. Okay. So for example, if we want it to start at 0, we need to send it the message 0, and it will start at the beginning at 0 milliseconds, so at the beginning of the buffer. So let's just do that quickly. So 0 into the groove object. And we also, so along with a starting point, we also need to dictate how quickly we want the groove object to play back. Now the way this is governed is basically by a signal. If it receives a signal value of 1, it plays at normal speed. If it receives a signal value of 2, it's double the speed, and so on and so forth. So for the second, let's go sig, just like we did up here, but let's go 1. We want it to play back at normal speed, and we hook that up. Okay, so this is dictating the playback speed, and this is dictating whereabouts playback starts. So now let's just see if we get some audio output from that. So create the gain object so we can control volume, so gain tilde, and that creates our nice slider. Hook up our groove object to our gain slider, and then we just need an audio output, so DAC tilde digital analog converter 1 space 2, so outputs 1 and 2, we'll listen to it in stereo. So hook up the left outlet of this gain object into both of our DAC outputs, and then we just need a toggle that will allow us to turn the audio on and off. Okay, so comment audio on/off. Cool. So we've got some audio. Double click on your buffer to make sure you've got some audio in your buffer. Let's turn this up, press 0. Sorry, my audio was already turned on. I'll just turn it on again. Press 0. Okay. Let's close that down. Okay. So we can hear that we're playing back from the buffer. So now let's just record some stuff in to make sure it's working okay. So I'm just going to press record up here. Hello, I am now recording into the buffer. I am now recording into the buffer. Turn it off. Go back down here and press 0. The buffer. I am now recording into the buffer. Okay. It's crackly on my computer because I'm bridging the audio, so I can do the playback. So I can record the video. So it shouldn't be crackly on your computer. Okay. So we can now play back from our buffer. So what's next is that we want to be able to have this looping. Okay. So we want to be able to loop our audio that we've played in. Now the Groove object is programmed to listen to the message loop, and when it receives a 1 after it, it turns looping on. When it receives a 0, it turns it off. So we can do exactly the same as we did up here. So in fact, let's just copy and paste these two objects. Oops. Let's just copy and paste these two. Change this to loop. Actually, we don't need this one, so you can delete that. Let's create a toggle. And what this will do is, you don't need to worry about building this bit on your keyboards, just so I can show you when we turn it on. It says loop 1, when we turn it off it says loop 0. We plug that one into our Groove object, turn it on. The buffer, I am now recording into the buffer, into the buffer, I am now recording into the buffer, into the buffer, I am now recording into the buffer, and you can hear that when we turn it on it loops, okay? So we turn it on, start the audio, loops, turn it off, it will finish the loop it's on, and then it will turn off. Great, okay. So we now have a control for turning looping on and off. So let's just do loop on/off. So remember, C on your keyboards to create the comment box and just type that so we know what that parameter is doing. Cool. So next, it might be useful for us to be able to see, without having to click on our buffer object, what audio we've recorded in. Now there's an object that really nicely allows us to do that, and it's called waveform tilde. So you can see here buffer, viewer, and editor. So you press enter, it will bring up this form, and this form is, and this object here will appear, and it will allow us to record into the buffer. So if we tell this object which buffer we want it to display by creating a message object and typing in set loop 1, so that's the buffer we want it to access. We connect the two up and then click the message object, you'll see that it now displays the information that's stored in our buffer. So just to go through that again, this object here is programmed to listen to the message set, and then when it hears the message set, it takes the symbol afterwards and uses that to search for a buffer, which it then links itself to and displays. Okay, so it's basically displaying exactly what we can see here, but within our patcher. So now if we record into it, you'll be able to oops, where are we going? You'll be able to see that we are recording into the buffer, okay? And it displays it in real time. We turn it off, it stops. Okay? So, now we have this object here. What we might want to do is record some audio in, but we might only want to be playing back this bit. So if you play like in a bar, you want to be able to define the start and end points of your bar. Yeah? Now, we can do that by defining the start and end points of the Groove object. So here it will say loop minimum, and loop maximum. So if we create two integer boxes and connect that up into the minimum and that into the maximum, so let's just, so I on your keyboard, remember for those, press the comment box and type in loop start is here in milliseconds and loop end in milliseconds. We can then define, so let's say 1000 here, 1500. That means it will play back 500 milliseconds around about here. We can then define a loop. But what's not helpful is we can't see whereabouts that is on our waveform. But usefully, this object here, if you hover over the inlets, will allow you to input a start point in milliseconds. So if we pop that one into there, and this allows you to input the endpoint. So if we connect those two up, and then type those values in again, so 1000, 1500, it actually highlights the part of the waveform that we're looping. So now if I want to say this clap here that I recorded in, I wanted to just hear that, I can do this, turn looping on, and then press play. And you can hear, I'm just hearing that part of the audio, and we can make it shorter. Or longer. And it plays it in real time. But what you would notice is when I start this here, we're hearing this part of the audio before this bit, when naturally we might only want to hear this bit. Okay, so just let me recap on that. When I press 0 here to start, it's starting from here, not from here, but then it's looping round, so it goes from here all the way to here, and then it loops this bit highlighted in green. So actually we want it to start here. And the way we can do that is basically we need to send it, instead of this 0 here, we need to send it this value here. So we need an object that will store this value, and then when we click it, it will start the loop at the point we've typed in. And there's a special object that does that for us, and it's called int, store an integer value. So basically, we take this start point, pop it into the right inlet of our int object, and then we connect the output of our int object into the groove object, and then we create a button. Okay, so B on your keyboard and connect that to the inlet. And this will play loop. Okay. So basically what's going on here, let me just recap, is this value here is stored in this object. And when this object receives a bang, it sends that into the groove object, which will tell it to start from this point, and then it will loop around. So instead of it starting here and then having to reach the end before it starts the loop, it will start the loop immediately. So let's just test that out. So we type in 383 again, so it's saved in, turn looping on, and it plays it in real time. Okay, so now we're able to start the loop at the correct position. So we've got a pretty useful patch here. You know, you could hook up your guitar pedal to this to see if, or you could hook up some buttons to this, sorry, to make like a little guitar pedal that you could use on stage. And you could have lots and lots of different buffers that you record into, so you could layer stuff up. But what's quite useful as well is when you're recording something in, you probably want to be able to hear it. Yeah, at the moment we can't. We can't hear on our headphones what we're recording in. So we actually should have a fader here for the recorded out signal, and another one, so gain object. Remember, this is a gain object. Connect that to the output, like so, and then we can hook our input signal, our dry input signal, into this one here. So if we turn this one up, we can hear ourselves. Obviously, I've not got headphones on at the moment, so if I turn it up, I get feedback. But you'll be able to hear yourself. So this is your dry signal, and this is the signal from your looping patcher. Okay, so what else might we want to do to this? So as a final thing, because I think there's a lot already in this video, but as a final thing, let's manipulate the speed of our looper, okay? Which, remember, is this value here. So if it receives a 1, it's normal speed. If it receives a 2, it's double the speed. So if we create a floating point number box, put a comment back here, say comment box here saying playback speed, and connect that into our signal object, we can actually then control the playback speed of the sample. So let's get looping on, play our loop, and let me type in 2. Or 0, and it stops. If I type in -1 here, it will be reverse. -2, reverse. Double the speed.